So here, we're still doing the same stuff we were doing before, where we are polynomials, and now we're multiplying binomials. So when I look here, what's different about this problem? There's a binomial, and that binomial is being squared. What does it mean when we square a number? We are multiplying it by itself. So if I was to multiply a plus b by itself, that means I'm going to be looking at a plus b times a plus b. No. Because when I have a binomial times a binomial, I have to distribute. So I'm going to have a times a, then I'm going to have a times b, then I'm going to have b times a, and then I have b times b. So it's not just a squared and b squared. You have to distribute. So now what is a times a? That is a squared. What is a times b? AB. What is b times a? That's AB. Right, put them, you can rearrange it. Let's put them alphabetically. And what is b times b? Now do I have any like terms? AB and AB. If I combine those, that's going to give me 2 ABs. Remember, they each have a coefficient of 1 when I'm combining like terms. I keep the variables the same, and I do what the numbers tell me to do as far as combining. So in this case, a positive 1 and a positive 1 combine to be positive 2. Here's the next one. 5x minus 3 squared. So if I'm squaring this binomial, that means I'm multiplying 5x minus 3 times 5x minus 3. If I distribute, I have 5x times 5x. Then I have 5x times negative 3. Then I have a negative 3 times 5x. And then I have a negative 3 times a negative 3. So now 5x times 5x is 25x squared. Both of them are raised to the first power. Oh, look, I wrote this down wrong, didn't I? This should be 5x times negative 3. So what is 5x times negative 3? Negative 15x. Negative 3 times 5x is negative 15x. Negative 3 times negative 3. Positive 9. Now, do I have any like terms? Negative 15x and negative 15x. If I combine those, that is negative 30x. So because we are squaring this binomial, that means we are multiplying 3x minus 4 times 3x minus 4. When I distribute, 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. Negative 4 times negative 4 is positive 16. And then I have like terms here that I need to combine. So that leaves me with 9x squared minus 24x plus 16. So now I'm going to multiply a times a, which is a squared. A times negative b, that is negative ab. B times a, that is positive ab.
Catherine Eskew, come to the high school office for checkout, please. Catherine Eskew, come to the high school office for checkout.
And then b times negative b, that is negative b squared. It is. You notice my like terms here. I have a negative 1ab and a positive 1ab. Those terms cancel out. They go to 0, which leaves me with the a squared and then the negative b squared. All right. Let's talk a little bit about some of this, because the next lesson we're going to be learning about next week has to do with this. Okay? This is a special case called the difference of squares. So to have a difference of squares, we need to have a binomial. Is this a binomial? Yes. Notice the first term is a squared. That is a perfect square. You guys remember what perfect squares are? 1 times 1 is 1, 2 times 2 is 4. So 1, 4, 9, 16, 25, 36, 49, blah, blah, blah. Sorry. Well, it turns out that a squared is also a perfect square, because a squared is just a times a. B squared is a perfect square because it is b times b, and we are taking the difference of those squares because we're subtracting. So this is the difference of squares. Now, here's what happened. Look at my two parentheses that I multiplied at the beginning. What do you guys notice about those two binomials? They're not exactly the same, but they are almost the same. What's different about them? The sign between the terms is different. One is positive, one is negative. So these two binomials, these have a special term as well. We call them conjugates. So anytime the sign between the numbers is different, those things that are being multiplied are called conjugates. And it happens, you see how these things canceled out? That happens every time you multiply conjugates by each other. So if you multiplied x plus 5 times x minus 5, the two middle terms are going to cancel. If you multiplied 3x plus 11 times 3x minus 11, the two middle terms are going to cancel every time you multiply conjugates. Okay, so what happens here if I distribute 5x times 5x, which is 25x squared, 5x times negative 7, that is negative 35x. What about 7 times 5x? That's positive 35x. Look what's happening there. Those middle terms are canceling out. And then I have a negative 7 times a positive 7, which is going to be negative 49. Here, and let's see. What is 2x times 2x? That is 4x squared. Okay. Now, what is 2x times 4? That is positive 8x. Negative 4 times 2x is negative 8x. And then negative 4 times positive 4. Negative 16. So you kind of messed up in 2 places, right? You messed up on that multiplication. And then when you combine these, what did you get when you did 8x minus 8x? It should be 0x. And what is 0 times x? 0. So if it's 1x, we can write x. But if it's 0x, we don't write the term at all. That term is gone. So those cancel. And we're left with 4x squared, and we're left with a negative 16.